Cosmos DB store procedures are easier than they look, and I want to share my findings so that you can build your own. But first, my struggles with Cosmos DB is threefold. Firstly, they're written in JavaScript, which may be difficult coming from a T-SQL background or different programming language. Secondly, there's this thing about having the store procedures scoped to a container partition key, and that just adds to the overall confusion when it comes to the store procedure, SDKs, and the NoSQL constraints. So I did some digging, I looked at videos such as this one, maybe trying to find a blog that might help, and with my digging, I didn't really find much. But I had an idea, right? So what if to learn NoSQL, we use SQL? Hear me out. So basically, my tactic is to take the generic components of SQL, the blueprint, if you will, of a stored procedure, and apply that to Cosmos DB and then just fill in the gaps. Hopefully that then should work. But first I need to build this blueprint, and my blueprint is three parts. There's the signature, the logic, and the environment. The signature would be the parameters and the name of the actual stored procedure. The logic would be the necessary steps that would happen within the store procedure. When I say steps, I mean the actions, the CRUD operations, and then the environment would be the database, the scope, the tables that all of these steps run against. So if I had to summarize, this code named so-and-so, XY takes the list of parameters, it does these following actions to this database, to this table, or to these records. That, in a nutshell, is the blueprint for a stored procedure. And it works pretty well in SQL. So we have our database as our environment, and lower down as we go along, there might be a few tables that we might list out. We have the logic, which, as Phil mentioned, would bring out the tables, but also the CRUD operations that we need to do to those tables. And then as a signature, we have declare store procedure as store procedure name with the list of parameters and so on and so forth. So SQL, pretty done and dusted, pretty pen and paper. But for Cosmos DB, however, it's slightly different because it's running as a JavaScript function. So at the top for the environment, we have the local variables for the context and the link to the context. Then for the logic, we have a CRUD operation running on top of the collection variable, which I'll explain a bit further. And then at the top for the signature, we have the JavaScript function name, as well as the parameters that the function receives. There's a bit of a nuance to this, but this too, I owe you an explanation. Then at the bottom, we have the output that the stored procedure returns to the client that sent the request. And one thing to note is that the methods in pink, rose, magenta, what have you, those operations are specific to the Cosmos DB JavaScript SDK. And well, let me explain them. So we know that Cosmos has databases, and those databases have collections, right? And in those collections, we have data, documents split out by a certain value, and we call these separations, divisions, we call them partitions. Cool. Now, with those partitions, if an external application, which could be anything really, wants to talk to or modify or mutate the data that's in Cosmos using a stored procedure, it does so using a context. And what a context is that it provides access to data within a given partition. And why we use partitions is because we don't want to run operations across the entire Cosmos DB database because we build for that entire operation. Rather, we want to do operations against a subset. And in this case, we're doing an operation against a specific partition. But because we're doing an operation against a specific partition, we'd find ourselves that the application needs to know that partition. So when calling a stored procedure, not only are we providing the parameter and calling the stored procedure by its name, but we also provide a partition key. And this, in a sense, is setting the context, or should I say, get context. So once we have a context, we're able to get all of the documents within that partition. And to get all of those documents, we say get collection. And once we have the collection, we need a way to almost reference the collection. So the collection has a way to reference itself, and we call that get self link. Awesome. So that's in a nutshell some of the pink operation, but there's more. Not only does the context carry, give access to the documents within the partition, but it also gives access to the request and response variable. So you'd find that we're able to get response. And once we have that response, we're able to set it, and then the client application has a JSON view of some of the data that was operated, or whatever the use case is. You'll see in the examples that we bring out forth. So those are the pink items. So to summarize, right, the context itself, right, is able to provide access to the partition and the data within the partition, as well as give access to the request and response variables. So you can hear your application's request, operate on the data within a given scope, ergo within the partition, and then respond back to your application. All of this is happening within that stored procedure JavaScript view. But one thing to note is that because we are operating on a partition, if there's ever a use case where we need to change all the data within Cosmos DB, we'd find ourselves running the application or the stored procedure multiple times until the entire data is changed. So this then brings up a case of selecting the partition key and ensuring that we choose the right partition key so that we don't run as many stored procedure calls as possible. But regardless of how many partition keys or selecting or query they have, we do know that the context is working hard in the background to ensure that all the relevant, ergo partitioned data is mutated as per our stored procedure call. So you could say that working with Cosmos, a lot of things change once we know the context. Okay, cool. So in terms of the stored procedures themselves, I've placed 4 here, but there are more methods that could be applied. So for create, for read, for update, for delete, it would be these functions here. And for each of these functions, they would operate on a document or documents. They would have an additional parameter based on that document, and then they would have options. So these options are additional things that we want done in the CRUD operation, and what we notice is that they all return Boolean, basically a true false, did this work, didn't it work, and they all have a callback function, which is almost like a acknowledgement, if this then that type of function. If we created our document, we want a callback function to maybe return the document back to the client that called the stored procedure. If we had a stored procedure to read documents given a specific criterion, we will want to then return those documents back to the client. So they all have callback functions. But one thing I also notice is that when we're creating and reading documents, we're using the collection link. So the list of records, the list of cars, the list of chairs, the list of fridges, if you will. But when we're updating and deleting documents, we're using the document link itself. So it would be the green car, update that. The blue fridge, delete that. And when we are using updates or deletes, and we want to delete 5 cars, these update or delete functions, you basically see them in for each loop. So when I was looking through the documentation, I saw that if I wanted to delete a set of data, I would basically have to put this update document in a for each. So for each car, replace document link for that one car and that car, and so on and so forth. You'll see in the examples I'll have. But first, I placed the SQL approach and the Cosmos DB approach side by side just to basically look at the syntax. SQL came up to 11 lines, whereas Cosmos DB had 38 lines of code. And Cosmos DB, it looks a bit more analog in its approach, whereby each component of the stored procedure has to be patched together, which we'll dive into. try to shorten the code because I know with JavaScript you can place a function in a function as a parameter of a function and so on and so forth with closures and all of those good things, but I only got 32 lines of code. So aesthetics don't really apply here. But in today's example, we'll create a new movie listing. We'll list movies older than 30 years. We'll update a movie genre by its ID, and we'll delete movies for a given genre. Before we run the demos, allow me to set the scene. We'll be using Visual Studio Code to go through the code as well as see the outputs. I will jump back and forth in between Visual Studio Code and the Cosmos DB frontend as well. Within the files, we have all of the files that we need to run the code. And one thing we did is that we created this nifty little Python script to basically take the movies from this large CSV, split it into smaller CSVs, and then upload all of the data from this first partition into Cosmos DB, which we can see in this Cosmos DB extension. So we have the documents here. I can go into one movie and we can see the structure for the document. And for the partition key, we created this partition key called primary genre. And within the Python document, what it did was that it took the genres, which was split by a pipe. It took the first item and created the partition key using that first item, and it called that partition key primary genre. Also, one thing I wanted to clarify in terms of the stored procedures is I did mention that there was a bit of a nuance in terms of the function name, and that nuance is that the function name within the JavaScript method doesn't necessarily have to match the Cosmos DB stored procedure name. So you could have update genre here, but a different name here, and it would still run. But then the trick is to use this name when you're calling the stored procedure. But to avoid any confusion, it's best to have the same name across both the function as well as the Cosmos DB stored procedure name. So looking at the insert, I'm going to start off with the Python program that calls it. So with the inserting data, what we're doing is that we're just pulling a random movie from one of the partitions. And once that movie is pulled, we're then just going to upload it to Cosmos DB using the store procedure. So in pulling the movie, what we've done is that we're just basically reading from a CSV file. We're getting a list comprehension of all the records. And from this list comprehension of all the records, we're asking Python to choose any one at random, and then that one then is assigned back to a movie variable. Then what we're doing is that we have a calculated partition key, which I'll explain later, but basically it's taking the random movie and generating a partition key, but this will appear again later. We're then printing it out. Then what we're then doing is that we are changing the format of that random movie from a dictionary to a JSON string. And then within the second part where we upload the movie, we're basically using the Cosmos DB SDK to run a stored procedure. So in these 4 lines of code, I have saved off the Cosmos DB URL and key within local variables, and then I'm just calling a get environment variable to push those local variables into a command that creates a client, and then that client will then operate on this database. And then once it operates on this database, it's just going to then operate on the movies container, and then from that container it's going to run this store procedure that is named insert movie, and as a parameter it's going to take the random movies and push it up as well. And then for the partition key, we're going to use the calculated partition key, and then we'll just print the results. But then looking at the store procedure itself, the code sitting there, what it does is that we have this collection link over here, and from this collection link we're going to then operate on. But to do this, we're going to take the movie that was passed in as a variable. We're going to just pass it into an item. Then we have this function basically called set primary genre, and in set primary genre we're doing basically the same type of operation that we did in the initial Python script that populated the entire Cosmos DB database. So in a genres item, it's separated by a pipe, and we're taking the first item from that pipe to set our primary genre, which we can see here at the bottom. So this item, which was the movie that was passed in, we then creating an attribute called primary genre, and we setting it to the result of the set primary genre method, and we passing in the genres. A bit of confusion, but whatever we got as a parameter, we're passing it into a function that will generate our primary key, similar to the initial Python script that populated the entire Cosmos DB database. And in addition to that, we're doing some other applications here. So the row ID and the item ID, we basically generating it from the item. So we're swapping around some of the attributes as well, so it matches the format of Cosmos DB. So this store procedure, it takes in a value and it mutates that value and does the validation on top of that value to insert it into Cosmos DB. But then that poses a question that you can think in terms of your own applications. Is it that you would rather calculate the partition key and do the validation, the checking, the formatting within the client application, or do you want to do all of that within the Cosmos DB stored procedure? So that's something interesting we can think about. But what we can't do is that we can't change context within the Cosmos DB stored procedure. That's why we have to have the partition key prior. How can I explain this? Well, if we look at the store procedure itself, it's working within a given partition, and we can't change partition mid-store procedure. A nice analogy to explain is apples to apples, dust to dust. So if this was in the drama partition, we're already in the drama partition, and then if we were to change the partition key and then try and insert it into the partition, it would give an error. So going back to a few slides, there was red, green, yellow, and blue. So having a change of partition would be all of these blue documents and then one red document in between, which doesn't work in the land of machines. It works perfectly well in the land of humans, but not in machines. I hope that then helps explain it. So it's a question: do we do the mutations within the client application, or do we do the mutations within the stored procedure? But the only mutation that we can't do is changing partition key in the stored procedure. Everything else is perfectly fine. So that's the first few lines, but then at the bottom we have this boolean is inserted, and it takes the collection and it creates a document on the top of that collection. So it creates a new document within that collection, and to do that it takes the select collection self link and the item. So the data that we've been mutating, validating, and passing, we pass that as well as a variable in this create this document. And the callback function I've placed as an entire function. It takes an error and the inserted movie. There's a difference here. The inserted movie is the result of create document. So the new movie that was inserted comes in here as a parameter. If there's an error, we throw that error. If there isn't an error, we're going to get the context. So all of the drama movies, for an example, get the response, and then set the body. And what we're setting the body is to the inserted movie, so the new movie that's within Cosmos, as well as the item that we were mutating. And we're sending this back to the client. So the client application can see, okay, what was in Cosmos and what are the changes that was made within the store procedure. Maybe it will help out in terms of testing, or there are some other cases whereby you can return the inserted movie or the inserted item, the mutations we made, or the updates we made, as well as maybe the parameter that was received. Maybe this might help in terms of like fact checking and ensuring that the process is consistent throughout. So that's the insert movie portion. And then if that worked, or if it didn't work, rather, we would throw an error. And if it did work, then this portion here, get context, get response, get set body, would be returned back to the client. So let me run this. I'm first going to jump into my execution folder that I need to spell correctly, and then I'm going to run the Python script. Awesome. So we can see here that we're working within the drama partition, and we have this item here that needs to be built into a partition key. So we have drama or war, and the store procedure needs to take drama and set it as the partition key. So if I go in here, this is the item that was returned from Cosmos DB, and we see that it's an array of items. And the first item, if I look for primary genre, we see that it's drama, and we jump back up here and we see that it's drama. So it changed the primary genre to drama, and then it inserted it. So the client application needed to know that it was working within the drama partition. I can create another video maybe to further explain on this, but let me run it again to show that it was random and my examples of drama are not pre-calculated. So if we run it again, we're running on drama, it does the same thing, so it inserted that one. And if we run it again, oh, it's working again within drama and it inserts it. So if we jump back to our code, and let's say we change it from calculate partition key, takes it from genre, and if we run it again, we have action. So in this fourth one we have action, and it's going to, in the list of action, mystery and thriller, is going to take action as its primary genre. So let me search for that. Primary genre is now action, and on this side as well, primary genre is action. Awesome. So the insert works. It just poses some questions in terms of how you want to insert the data. Do you want to make the changes within the Cosmos DB environment, or do you want to make the changes within the client application? Regardless of where we make the changes, the client application always needs to provide the primary genre, the partition key needed to insert the data into. So for the select example, we're going to query all of the documents within Cosmos that are older than a given year. And what I have open here is the Python script that calls the stored procedure that does that function. It specifies a variable called years ago, which is 30 years ago, and then formats it. And then here we have the partition key to run against. So this partition key here is for drama. So basically what that would mean is that we would be querying all the drama movies older than 30 years. If we wanted to query movies of another genre like comedy, action, or thriller, then we would need to basically run the same Python script that many times, which speaks to the slides that we have aforementioned. Then below we have the stored proc name, and then some of the SDK specific variables and syntax to call the stored procedure. And as aforementioned, we're using not only the parameters to call the stored procedure, but as well as the partition key. But not here for Python, we're here for Cosmos. And I'll dive into the JavaScript that does the stored procedure for Cosmos. So we have the name on top with the variable, and then as mentioned, we're using collection variable, which is getContext.getCollection. So we get all of the documents for that collection, which is basically the partition drama in this example. Then we have the where query, which is a object that contains the query that we're going to run across the documents. And then we have the CRUD operation itself, which returns that Boolean, which we're storing in a variable called isAccepted. As mentioned, this query document has parameters, so it takes the collections link, which is collection.itself link. It takes the where query. So notice here how it takes the where query object or variable, as opposed to having the entire where query sitting in here. So you can use either option. And like I did below, instead of having a reference to the callback function, I placed the entire function in as a parameter. And that function itself actually takes an error, a feed, and options. And if there are any errors, it throws an error. If the feed is null or if the feed has no length, what that means is if there are no movies older than 30 years, then we want to return a response back to the user. And we do that using the get context again. So we're getting the context, we're getting the response, and we're setting the response to no document found or any appropriate error message. But if there are movies older than 30 years, then we want to set the response to the list of movies. So what we do is that we take the feed, which is essentially the list of movies that came back from the query above, and that feed we place into an object called body, and all we're doing here is doing response set body to that feed. So we're using json.stringify to do that. And then right at the end, we have if not accepted, throw an error. So if the CRUD operation did not work, collection.query documents, if that didn't work or if it returned false, then we want to throw an error. But if it returned true, then we exit out of the stored procedure, and the response back to the client would be essentially that list of movies. So I'm going to run this now. First, jumping into the folder that hosts the Python application, and I'm going to call it. So select. And it's going to start to run, and we'll notice that, okay, we're querying drama movies older than 1992, and it returns the list of movies. So looking at the movies, we have, use the find function. So we have 1940, we have 2006, we have 2006. Okay, there are some caveats in terms of working with dates in Cosmos DB. This blog from Microsoft shows that it's between Cosmos and JSON, and how they work with or support date time formats. So I miscalculated on that part, my apologies. What this does do is give us opportunities to tinker and find how to get the data to work. So if the current way of pulling data for a given date time doesn't work, how would we do it? Would using this date time format provided here work? Or is there something we do on the client application or within the Cosmos DB store procedure that might get it to work? I had some ideas in terms of maybe even using JavaScript. So using the JavaScript process and maybe pass the date time there in terms of both of the input and the documents that are pulled back. There might be even some ideas in terms of using the date time as an integer or as a big int, and maybe using that to compare the dates and maybe return the data across. But it is something we can work on in future videos. But for this example, it didn't work, but there are some ideas we can pull across in future videos. In updating a movie, what we're going to do is that we're going to take a specific movie by its ID and update its genre. So we have a movie here, Citizen Kane, and similar to the insert example, we need to specify the partition key before we call the store procedure, and in this case it's mystery, and what we want to do is change the genre to drama, and then the generic process below. But one thing I want to note here is that we are changing the genre and not the primary genre, because then this would cause a context partition key conflict. If we wanted to change the primary genre, what we would need to do is to download, or rather select, the movie Citizen Kane, get the result back into the client application, update the primary genre to drama in this case, and then run an insert statement to insert the new movie back into Cosmos DB, but we can't use Cosmos DB stored procedure to update a partition key, because then that would cause a context partition key type of error, which I can show in a separate video. But what I can show is that if we jump into the Cosmos DB instance using this extension and we open up Citizen Kane, we can see that the primary genre is mystery. We have genres mystery and drama, but there is no attribute called genre which is set to drama. So we're going to use this stored procedure to make that update to this document. And if I jump in the stored procedure itself to explain it, we have the function name. It takes genre and an ID. So the genre we're passing in is drama, and the ID we're passing in is Citizen Kane. We are going to get the collection using the context. So the context in this case is the partition key, which is mystery. So all the items that are mystery are going to save into a collection. We have a collection link, and then we have this where query similar to the select. So when we're doing an update, basically what we're doing is that we're selecting an item, and with that item, we are updating that item and then replacing the original item with the mutated item. That's why Cosmos DB is a bit analog in its approach. But we have this where query, select movies, where the movie ID is the ID provided, so we'll get back Citizen Kane, and then we have this execute where clause. So this Cosmos DB approach, or this store procedure rather, I built it as a layered, almost imperative approach, whereby I have the functions laid out, and then I'll just chain the functions one after the other. So the one on top is just going to execute the where clause, and what it's going to do is that it's going to return collection.query documents. So I'm passing in the collection as a variable. I could have just have the collection run through because this function is within the scope of the bigger function, but just for the sake of testing and sanity and making sure that I'm not missing anything, I made all of the functions have parameters as opposed to no parameters and global variables. It just makes things a bit easier in terms of following through. So this function takes a collection link, and it runs the CRUD operation to query the documents using the where query that I stated above. Funny how I'm using the where query as a global variable when I just spoke about using. Anywho, it takes the where query as a parameter. There's no options, and then the callback function is the query callback. Notice when we're using the query callback, we're not having it as a function with the parameters. The parameters are automatically passed in because it's a callback function. So this callback function would then take the error, the documents, and the response. So similar to the previous slides, it takes the documents and not the document, because this where query would return an array. Even if there's just one item, Citizen Kane, it will act as an array. So if there are any errors, it will throw an error. And if the array that it took in has no documents, then we throw an error whereby the client application would see no document found. But if these two if statements do not run, then the apply update function would run, and this would take the documents and the genre, and then I just end the query with a return. The update function, which took the document and the genre, would then set the document genre to the genre passed in as a parameter. And then once that is done, then we're running another CRUD operation for the actual update. So we're doing collection.replace document, and we're passing in the document reference, which is this document that was passed in. Its reference, we're passing it in. We're passing in the entire document, right, as well. So the document that was passed in and the up genre was updated, we using that to update the document that is referenced over here. Citizen Kane, the previous example or the previous instance or the previous record that had no genre called drama, we're updating it with this change over here. And then there's the callback function, which is update callback. So once the replace has replacement has been done, we're calling this update callback. And if there is an error in replacing the document, we throw that error. But if there isn't an error, then this update callback would have ran. Update callback receives an error and a replace document as a parameter. If there is an error, then we throw the error. If there wasn't an error, then we're using the context, which is the partition. We are setting the response to the replace document. So the client application would see the replacement, but you can always change this to be whatever fits the use case. And then if right at the end I'm setting a variable is updated equal to the result of this where clause. So right on top, the where clause that starts this document, or the execute where clause function that starts this domino effect of functions. If this runs, then this will run. If this runs, then this will run. If this runs, then this will run. And if all of them are true, then execute where clause will return true. If any one of them are false or throw an error, then execute where clause would throw an error or return false. And if it does return false, then we throw another error here, unable to update document. But then if I run this, so I'll jump into the execution folder, and I'm going to run the Python application. So exec update. And then what it does is that it returns the update that was done. So we have Citizen Kane, and then notice here how we have this attribute called genre drama. So it didn't have that attribute before, but now it does have that attribute in. And if I go into the extension and I click on Citizen Kane, we will see here right at the bottom. Okay, I need to refresh this first. So once it's refreshed and I go into Citizen Kane, we will see that this genre has been updated to drama. And this could be for any one of those attributes. So I'll even run a test whereby I will change the code here, where I'll change the code here to test. I'll save this off and I will rerun the Python application. And we see that the genre changed to test. And if I refresh the documents and I open Citizen Kane, we will see that the genre changed to test. So that is in a nutshell how we would use the update function within the Cosmos DB stored procedure environment. We'd first need to select the document or documents, and then for the document that was selected, what we would then do is that we would run a callback function that would apply that update. And notice in this case, we are just updating the one document, but if we're updating multiple documents, there would be a for each in between the methods, which I can do in another example if needed. So that in a nutshell is the update for Cosmos DB. The deletion example is a bit more quicker in terms of explaining. So what we have is a case whereby we state a genre, and within Cosmos DB we delete all movies of that genre. So we have a genre fantasy, and we're going to run a stored proc that basically deletes all movies with the genre called fantasy. And we're using the genre as both the parameter and the primary key. So we'll be in the fantasy stored proc partition, and we're going to delete all movies with that partition key. Jumping into the actual store proc itself, so we're taking genre as a parameter, we doing the generic get context, and we have a counter for deleted documents as well. So we be able to count how many documents were deleted. So similar to the update version, we first need to query all the documents that we want to affect and then affect the documents. So we're running a query that says select movie from movies, whereby the primary genre, which is the partition key, matches the parameter primary genre. And the parameter here, we're going to set the value to our input. So that's our query. And then first we're going to run a function or look through a function called query movies of genre. So this function here takes the collection as a parameter, and then it runs the CRUD operation to query all of the documents, and we'll use the query as the query and the callback. So if this runs, we're going to run a query callback, and in that callback, if there's an error, we throw the error. But if there's no error, but the documents from the query is 0, so if there are no documents to delete, we're going to throw an error, say that there are no documents found. But if these two guard clauses don't execute, then we will execute the deletions. And in execute deletions, what we're doing is that, similar to how we've been saying that working with a list of documents requires a for each, this example actually shows this for each. So we have all of the documents, and for each document, we're going to run an anonymous function that takes a document or the index of a document. So if there's 10 documents, it takes the first document, the second document, and so on. And it runs this function to firstly set the document genre to genre. So if it was fantasy, the primary genre is fantasy, and it will create another attribute called fantasy. And then once it does that, we do another CRUD operation. So this will return a Boolean, and we're going to use the document self-reference link. So there's an attribute within the document that aids Cosmos DB to reference that document, similar to how there's an attribute within the collection that aids Cosmos DB to reference the collection. So we're going to use that reference. We're going to use the entire document itself to delete that document. And then we have a callback function. So once that document is deleted, we run that callback function to do additional logic. But just before we get into that, if the document within this for loop is deleted, so if except is equal to true, then we're going to increment the amount of documents that were deleted. So it's basically a counter of how many documents were deleted as this for loop keeps running. And then if this didn't work, so if the document wasn't deleted, then we're going to throw an error within the entire for each. So this is almost like an all or nothing, whereby either all of the documents delete or you throw an error. And then if only some of the documents were deleted, then the client application would see that only 10 documents were deleted, or only certain amounts of documents were deleted, so they'd have to run this store procedure multiple times until all of the documents were deleted. There are a few more things that we could do here to make this slightly better in terms of statistics, or how long it ran, or which document did it try to delete but failed, so that the client application can better test or navigate around this. But this is just an initial example. Jumping into the delete callback, it takes an error, and it takes the deleted document or the deletion object that returns as well from the prior function. If there is an error, it throws an error, and if there isn't an error, we're just going to create an output object that has a count of the deleted documents, and then it returns the deletion object from the prior function. And then what we're going to do is that we're just going to set the response to that body. And then we have this right at the end, we have this are all deleted Boolean, which basically is a result of query movies genre. So similar to the update example, we running one function which calls other functions if that function succeeded. So it's like a domino effect running through. The alternative to this is to have all of these functions nested within each other. So maybe that's an idea that we can probably compare the two, see which one is a bit more easier to read or which one would give a better debugging or testing experience. But that's an idea for maybe some future videos. But in this case, if all the documents are all deleted, it returns a boolean, and if that boolean is true, we get the output, and if it's false, it throws an error to say unable to delete documents. So before I actually run this, we need to make sure that there are documents to delete, or better yet, we need to validate this example. And within Cosmos DB, I'm just going to run a test. So I'm going to run this query to select all of the movies where the primary genre is fantasy, and we get 80 items. Back in Visual Studio, I'm then going to run the method. So first I'll jump into the execution folder, if I can spell it correctly. And then I'm going to execute the deletion. And once it runs, we're able to see this output here. So deleted documents 80, so all 80 deleted. We could have made this better, whereby we could have put 80 out of 80 and 100%, but something that we can work on in the future. And then we have this body, so we get a 204, which is an HTTP status code for all is good. I know 200, all is good. It says as well current size in megabytes, the document size, the documents size, documents count, collection size, and the max. So it's basically a stat of Cosmos DB, the partitions, and how many documents are in that partition, and so on and so forth. Maybe something we can tinker on in the future as well. But I think if we jump back to Cosmos and we look at this query again for all the fantasy movies, we would find that there are none left. So this items returns is 0. Maybe let's do another example for horror. So we run this. So there's 154 items in here. I wonder if we change the Python application to delete all horror movies, if it will do the same thing, almost like a double test. As a double test, so I'll jump in here, I'll change this to horror, I'll save this Python document, I'll extend this tab, and I'll rerun the delete script that runs the delete stored procedure, and it returns 100 was deleted. But if we jump back into Cosmos, we will notice that we had 154, and if we run this execute selection, we would see that 54 are left. So this is interesting, whereby if we're running Cosmos to delete objects, it doesn't delete all of them in one go. We would almost need to validate if it deleted everything in one go. So when running your Cosmos DB stored procedures for, I believe it's deletes and updates, you'd almost need to build in some kind of a, I think they call it a continuation model, to check if everything was deleted. So that's something that we can take in terms of notes. So in closing, with some thoughts, I know that working through Cosmos DB will be a journey, and there's more things that there's out there to learn. I think one thing that helped was splitting the CRUD operations into smaller functions and having a layered approach in terms of this function does this function does that. There might be some cases whereby we need to nest the functions, but it's something that we can learn about. So JavaScript isn't that hard in terms of getting to know it. Secondly, there's this point of maybe if we have the client application know the partition key beforehand, it might resolve the issues in terms of running a query or a operation in one partition where it's actually supposed to run in a different partition. So there's a bit of more clarity around the partition keys and the get context, especially that one. Then there are some relatable software development kits that show that NoSQL is easier in this case than we thought. So the more documentation that I would be able to read or find or dig up, the easier it would make Cosmos DB to be. And I'm keen to hear from you if there's any documentation that you maybe have found that makes it a bit easier to work through the Cosmos. Because essentially, there's a lot more tinkering to do with Cosmos DB. There's ideas in terms of the date time format. There's ideas in terms of working with arrays and finding the best way to delete multiple documents or update multiple documents. So I'm keen to hear if there's any questions or ideas that may be on your side, because I definitely need to improve, not necessarily in Cosmos DB, but in tinkering and finding out how is the best way to work with all of this data and push it into this environment. And I have some ideas in terms of like using Cosmos DB with other NoSQL tools and pushing data through some convoluted diagrams and processes. So it's a lot. It's a lot that needs to be still done, but it's a journey. And I'm excited to go through all of this, and I'm looking forward to hearing from you if you have any ideas that might also carry us through this journey as Cosmos DB, but also tinkering with tech. I think there's some exciting things we can do, and I'm looking forward to hearing from you.